Hello and welcome to your third and final lesson on absolute values. This may be the shortest math unit in the history of all your math courses. So let's enjoy it, a nice easy unit, a nice easy week. So our first lesson was about learning the definition of an absolute value. So we know that the absolute value of a number is always positive. I think we've seen this every lesson. If A is positive, it stays positive. If A was negative, you make it negative. A negative is a positive. The absolute value of a number is always positive. And then our last lesson, we used that definition to apply it to solving absolute value equations. And now we'll apply that definition to graphing absolute value functions. This is a topic in grade 12. It comes up again. They do expect in grade 12 that when you come into it, you know how to graph reciprocal graphs and absolute value graphs. Just a heads up, grade 12 pre-cal, majority of the course is graphing. So grade 10 we graphed lines, grade 11 where everything's parabolas, grade 12's a variety of shapes. Almost the entire class is most of the course is trigonometry and graphing functions. So that's what's in store for you next year. So if you come in knowing how to do your reciprocal and absolute value functions, that can make life a little bit easier next year. Okay, so how do we apply that to our functions? So we have one rule. To graph y equals the absolute value of f, to draw an absolute value function, you basically start with the initial function, and then from that function, because absolute value has to be positive, any y values that are negative get reflected back up to be positive. So your x values will stay the same. If a y value is positive, it stays positive. The y value is negative, you make it positive. That's a fancy way of saying you just reflect everything above the x-axis. Our first unit in grade 12 math will be about transformations. We'll learn about reflections, shifting, stretching, things like that. So we'll touch upon these rules in grade 12, but like I said, absolute value graphs are part of grade 11 and grade 12 curriculum. So, for grade 11, the nice part is there's only two shapes they expect us to work with, lines and parabolas. Just like when we did a reciprocal graphs, we only had to work with lines and parabolas. But next year, you are expected to apply reciprocals and absolute value to shapes that are more than just lines or parabolas. So sometimes the graph is given to you, but sometimes it's not. So in grade 11 pre-cal, you are expected to know how to draw a line and a parabola on your own. And if you forgot, we'll reread your grade 10 notes. Remember, we spent probably a month and a half in grade 10 math learning different ways to graph a line. And then this year we spent the entire month of February, when we were all still together, knowing how to draw parabolas. So you should already know how to draw a line, any type of parabola. So this year we're just doing absolute values from those two shapes. So I've already drawn the line y equals x. This is the diagonal line where the x values are always equal to the y values. You do need a scale. Instead of a scale, I've chosen coordinate points. So you can do a scale and or coordinate point, same thing. So I chose 2 points to work with. So again, this part of the graph is fine. Anything above the x-axis is fine. This is the part that's not. So to do the absolute value of it, you take this piece that's below and just reflect it up. It's that simple. So the point -1 becomes the point -1 + 1. The x stays the same, just the y values change. Now this part is all the same. So I'm just going to retrace that. That part's the same, and this part was below gets reflected up. And that's it. That's a 1-mark concept mark question in grade 11 and 12. So anything that's positive stays positive, anything negative reflected up. Isn't this much, much better than the reciprocal graphs we just did? So that's it. The only mistake, though, some students make is that they'll just do this part. They'll remember to reflect, but then they don't retrace this part. If you don't retrace this, fortunately, we have to give you 0 out of 1. That's a concept mark. So you have to reflect this piece up and redraw the part that was stayed the same. So you need both parts. All that red part is your final graph. That's it. Let's try one example for a parabola. So again, given y equals x squared minus 9, so now we're working with a parabola. This time I didn't pre-draw it because you are expected to, well, you should be able to draw a line and parabola at this point. This has nothing to do with the school suspension. We learned how to draw lines and parabolas well before all of that. We learned different methods back in February how to graph a parabola. You can use whichever one is best. I think a lot of you are using table of values. Completion of squares works. That's a little time consuming. It only gives you the vertex, but like I said, you can use any method you want. I can use the factoring method just because it's nice and factorable. So now that it's factored, I know that I have 2 intercepts, one at -3, one at +3. I can tell the rules that we learned. This is a parabola that's been shifted down by 9, so I know that that's where my vertex is at, or I could have made a table of values. Either way, oh, and I wanted that all to be in blue with the original, sorry. So the original parabola, x squared, whoa, that went right through that point, perfect, perfect symmetry. So that is the starting parabola, y equals x squared minus 9. And then the question wants us to do the absolute value of that. So I do want you to draw the original and then the absolute value over top, because I need to see your original compared to your final. So again, let's start this part. I'm just going to retrace everything that was good. Anything that was above the x-axis was fine, so we do need to retrace it. This is the part that's a problem. You can't have negative y values, so to get rid of them, you reflect them up. Negative 9 becomes plus 9, and oh, a nice smooth curve. So again, you do need to have, well, I'm making it worse over top. You need to keep the parts the same and reflect up. And there you go, that's it to absolute value graphs. So like I said, much, much better than the reciprocal graphs we made it through last week. So again, good luck, have fun. This concludes the absolute value unit. We had 3 lessons. You will have a hand-in assignment to go with it. And then next week, we'll move on to another short, easy unit. So that's kind of what the rest of this course is like, kind of 1 week short units that aren't that bad. Okay, have fun, good luck.